Hello and welcome to TidyX, episode 85. TidyX is a screencast where we go through and explain how our code works. My name is Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And my name's Patrick Ward. You can find me on Twitter at OSPPatrick, and you can find the screencast on Twitter at Tidy_explained. You can hit us up on Gmail, tidy.explained@gmail.com. You can go to the GitHub repo and you can take out an issue, or you can get in contact with us via YouTube, where people come on, they like and subscribe, and then they leave a comment. Yeah, we appreciate it. And there you'll also find our Patreon link in the comments section there, or in the info section there. So if you like what we're doing, it's getting cold in Seattle now, so we love it. If you bought us a coffee, if you were into that, that'd be super cool.
Nice
Otherwise,
stout.
No worries. Yeah, or a stout. Sure. Yeah.
We got some good
Exactly.
news here. All right, so the last 2 months or so, we've been working on Tidymodels and getting our understanding of how to use that framework for machine learning and whatnot. And I've had a great time learning about this. And last week we did, or I guess not last week, we didn't record last week. 2 weeks
Holiday.
ago.
We had a holiday
We had a
off.
holiday off. 2 weeks ago, we did an episode on Workflowsets, which is how you could train a whole mess of different pre-processing recipes combined with your different models and have them kind of just all run and churn together. But in the examples that we chose last week, we did no tuning. They were just the models as they were. They were run very quick, very simple, just to explain the concept. Workflowsets. This week, we're going to tune.
Yeah.
We're going to
Yeah.
put it all
Which
together.
And we did do, I think it was episode 83, we did do model tuning, but that was one model. So now we're going to try and tune multiple models simultaneously. And that's the kicker with Workflowsets, is that you set up multiple workflows and then you run them simultaneously in parallel.
Machine go brrr.
With the idea then that everything is in one place, contained, so you can look at your output metrics and compare your models much easier. Traditionally, the way that you would do this, the way that I would have done this, would be to build each model within its native package, save an output that's like random forest preds, linear regression preds, support vector machine preds, and then make those comparisons that way.
And then any differences in your pre-processing as well.
Exactly.
It just,
and it opens you up to errors in copy and pasting code and all those things. Tidymodels, great way to keep everything kind of self-contained and make sure that you organize your thoughts in a nice little framework. So
exactly. So I will share my screen now so Patrick can see what we're doing here. So I will quickly escape out of full screen, share the screen, and Patrick can now see what we're doing. So yeah, so this is going to be very similar to past weeks. As we've talked about, we want to have like a standard workflow for how we do things. So a workflow on our workflows.
yeah, a workflow of workflows.
A workflow of workflows. A workflow set, if you will. So the data that we're using this week, I grabbed some new data just to keep it fresh and interesting. It's also from Kaggle, but it's also available on a machine learning data set website. But this is the link to get it from Kaggle. And it is on wine. So it's got a bunch of different... Actually, let's bring it in and get started with this. I'm getting ahead of myself. So we've got library Tidyverse for all our data manipulation needs, library Tidymodels for the Tidymodels work that we're going to be doing, and library Janitor for some data cleaning. We're going to set our theme to be theme light when we do our plots, just because we like the way that looks. And we're going to load in our data here. So we're going to use the read CSV function from read_r. This is the path to our data set. So we're going to have two different data sets we're going to load in initially. And we're going to mutate both of them, which is to add a new column. And we're going to create a new column called wine type. And one is going to be called white and one is going to be called red, because those are how the data are stored for us. And so we're going to bind that together with bind rows. So the raw wine white and raw wine red, and run it through clean names, which is from Janitor, to make the names actually nice for our use. And so now we're going to do a quick look at that. And so we have nearly 6,500 rows. It's a lot larger than the data we've been working with, which is kind of why I grabbed some new data. And 13 columns. So we have several. So this data set here contains 12 different parameters that you can chemically measure of wine. This is from some. It's shoot, I do not remember the actual type of wine. You can go to the Kaggle data set and look. I think it's like Portuguese wine, something like that. And they took a bunch of different wine samples, ran it through a bunch of chemical tests, and they also had a bunch of wine experts go through and give quality scores. And so it's a score between 1 and 10 of how good they think the wine is. And so then we could try to piece together and understand what chemical measures in wine maybe indicate a good wine. What is most indicative of a good wine or a not as good wine, or what's going to impact the score more. So yeah, it's a rather large data set, which I thought would be fun to be using, or larger. I guess it's not super large. We're going to quickly look across this to see if there's anything missing, and it does not look like there are any missingness. Nope, no missingness here. And then we're going to do a quick plot of quality here. So this is a histogram of the quality scores. You can see it's kind of centering around like 5 or 6 for both red, and kind of centering around 6 for white. And so basically what they're doing is the scores are just, there's a lot of middle of the road wine.
It's just they're subjective rankings, so people sort of gravitate towards the middle of the scale.
Yeah, so it is what it is, but we're trusting their expertise in their scale, or in their scoring. Here we wanted to do a quick plot of all the different measures so we can get maybe an idea of how we want to pre-process. Let me just zoom out so you can actually see the results here. I'll zoom back in once we're done looking at this. So I just wanted to take a look at this to see, are there any variables in here that we want to maybe be concerned about during our pre-processing?
Yeah.
And what I noticed immediately was, if you look at this variable here, it's probably a little bit small for you all, but this is total sulfur dioxide. Its scale is massive compared to all the other variables that exist. Like this goes up to nearly 300 for reds, and for white wines it goes up to past 400. And the same for free sulfur dioxide. I mean, this isn't as drastic for the red. It goes from 0 to like 80 or so, 70. For white, it can go nearly up to 300. So just the scale of this is a much higher than any of the other models. I mean, residual sugar can get a little bit high in white wine. But this was the one where I was like, whoa, that's a lot larger. We should probably do something about that.
Well, one thing I will say, too, about this plot, because we haven't done this before, but it is something that is super cool, is you used within Facet Wrap the ability to do this sort of like interaction plot where you have the tilde between the measures and the wine type. And so that allowed you to break out. That's why the title of each of your facets has the wine type as well, the measure, and then the wine type. And so that is interesting. That's always a cool way to, and of course, if you flip those, if you did wine type tilde measure, you would have gotten all of the reds and the measures together and all of the whites. And this way, you're actually looking at each measure relative to the wine type.
Yeah.
And so that is something that we haven't done before, but it is a good tip when you're looking at this stuff.
Top tips.
There you go. Yeah. See, cool.
All right. So let me undo that real quick. All right, so now let me zoom in again so you can see what we're talking about here. Patrick, do you want to take us through this set of things?
Okay, so as we've done on all the previous Tidymodels episodes, our next thing is that we'd like to split our data. So we're going to do a train test split here. We're going to use, obviously, pass it a seed because there's randomness to the splitting. We're going to do our initial split on raw wine, and we're going to make sure that we stratify this by wine type so that we have a similar proportion of wine types, red or white, in the training set and in the testing set. So, and then we're going to take that initial split and we're going to call the actual training data and then the actual testing data. So there's going to be what is it? I think it's 70% is the default in initial split, or what was it?
I think it's 1/5.
Okay, I couldn't remember what the. Yeah, maybe that's right. So 80% in the training set and 20% in the test set, I believe, or something like that. So we stuck with the. You could obviously change that, but we stuck with the default. And then the next thing that we do is we like to do our cross validation split right up front. I know if you look through different tutorials, sometimes people do this down where they actually create their recipes. We just split all of our data right from the start. So again, we're going to set the seed. We're going to do 5-fold cross validation. 5 is the default. If you wanted to change it, you could up it to 10. Just know that you're going to create more folds and it's going to take longer to run. So we're just going to stick with 5 for the purposes of showing this example. And so now that the data's split, we're ready to build our recipes. So remember, the recipes are all of the kind of pre-processing things that we want to do to the data. So within that recipe, we want to pass the actual equation that we're interested in, the function that we're interested in, and that's going to be, we're trying to predict quality from all of the other variables. That's the tilde dot, and we're doing this on the training set. That's what we're going to build our model on. And then as we saw in the plots, we noticed that sulfur was highly right-tailed with much larger values than everything else. So we actually create two recipes here. The first one is we're going to log transform sulfur. So what that's going to do is it's going to take some of those larger values on the right side and try and constrain them in so that everything's bunched together. The other recipe that we're going to do is we'll step scale it. So we'll actually do a z-score, right? So we'll put it on a scale of 0 with a standard deviation of 1. So those are the two ways we're going to handle or try and handle sulfur. And then the step dummy is basically taking the wine types and just spinning them out into their own columns with dummy coded 1 or 0, yes or no. So they're turning into binary, taking that binary information and turning it into its own columns. Once we run those recipes, we can kind of take a peek at what we did by prepping and baking that recipe. And so there, the only change is going to obviously be the sulfur. So we see it on a log scale, and then we see it on a scale transformed to a z-score.
Yep. And then you'll also see that we have our wine type red and our wine type white here. So those are just dummy variables 0 and 1.
Yeah,
just because we need
and
to do
they're
that
a double.
For,
They're a numeric.
couple of the models we're using this week.
Yeah. And then the next thing that we do is we're going to go through some model specification. So we're going to do 3 models. We're going to do a linear regression. We'll do a random forest and an XGBoost. So we specify these. We've done these before. You basically tell the Tidymodels the type of model that you want to run, in this case regression, and then you set your engine, which is picking the type of package that you want to run that model from. Here, we're going to set it to LM. We don't need to set the mode here, but we always do it because it's just good practice. There is no other way to run regression than regression. It's not a classification model. Random forest and XGBoost, however, once we set that random forest, we set the mode, we're going to set the engine to, so we set the mode to regression so that we let it know that this is what we want to run. And within that random forest function, we're doing mtry. So we're going to tune the number of variables that get pulled in the random developing trees as the features that get pulled from the data set to make the predictions on wine quality. We're going to tune that. And in XGBoost, we're going to do a boosted tree. And we're going to tune 3 different parameters. So we're going to tune the number of trees that we build. We're going to do an mtry tuning as well. And then the tree depth, right? So that's going to kind of help us prune the trees so that they don't get too deep and create a bunch of overfitting. And then we specify a learning rate. So that's basically the learning rate of the XGBoost formula. Again, we want to make sure that we tell it regression because XGBoost can be used for classification. We set the engine there to the XGBoost package, and both of these we set importance to equal true so that if we want to, we can extract the variable importance later on.
There we go. So now we've got all our pre-processing that we're going to do, the 2 different recipes that we've got, and we've got our 3 different models, 3 different models that we're going to be running: LM, RF, and XGB. So now we're going to create our workflow set. So this is now going to combine and cross them all together So we can create a total of 6 different types of workflows that we're going to be running here. And so you use the function workflowset. You set the preproc argument or preprocessing argument to be a list that contains the different preprocessing recipes that we have. And so we have the log sulfur recipe, which is the log transform, and the scaling sulfur recipe, which is the z-score scaling of the sulfur measurements. And then the models takes a list of the 3 different model types that we're passing here. We're going to set cross equals true. And this is what is going to allow us to apply both log and scaling to each of the arguments here. You can set it to be false, cross to be false, but then you need to have a pre-processing recipe for each one of your models. So that's not what we're wanting to see is the combination between all those. So that's why cross is true. And now we end up with a workflow set. And as I said, we have 6 here. It's interesting how it's set up where it's just recipe _1, recipe 2, and then the different engines or models that they have here. But I guess you have to label it some way. So then we've got all our stuff. And so the way you'll go do this now is we've got a ton of models are going to be doing a bunch of tuning under the hood. And so we want that to be parallel. We want it to be running in as many cores, in as many processes all at once, because it's embarrassingly parallel, which means things can be run at the same time and not impact the other thing. So we're going to use do parallel, and we're going to register 8 cores using the register do parallel function. And so that is going to set it up so that it's going to set up 8 new processes running in the background that I can then send jobs to. And now we're going to use workflow set, or we're going to use workflow map to train all our workflows. So we're going to pass workflow set into workflow map. We're going to set the seed to 22 for repeatability, replicability. I'm not going to try to say that. And then if you look at the workflow map, the way that you go ahead and start doing tuning of things is it takes this fn argument here. And by default, it's tune grid, but we decided to write it in here. And then, so the seed is for that replicability. And then the 3 dots there are any arguments that go into tune grid here. Well, tune grid is from the tune function or package. And so we can type !, tune grid to look at the different parameters that we might be passing to this. So we have resamples. And so this is the cross-fold validation samples that we pass to it. We could try to pass param info or grid. So grid is an argument that can take 2 different types of entry here. It can either be an integer, which is, hey, across the problem space, across the tuning parameter space, select n number of different potential variables and try those. You could also try to pass a data frame as well. So if you were explicitly tuning one of your workflows, you could create your own set of try these 4 different tuning parameter types or combinations of this and go. Here, we weren't really able to see if there's a way to pass maybe 2 different types of tuning grids. And so we just set it just be grid is 10. So it's going to try 10 different parameter combinations for our random forest and 10 different tuning parameter types for our XGBoost. And I think that's the point too. They don't want you to try to hack it all together and do everything. And then everything else we're going to leave as standard controls there. And so this takes a long time to run. So I've pre-run this. So I'm going to load in the results here, and we can take a look at what the results are. And it looks like you would expect. So it's a tibble that contains all the different workflows that we have, any information about them, any options that we have set, and then the results of the tuning of all of them. So that's very similar to last week, but instead of now just having the standard results, it's now got this tuned result that we've got here. And so we can do evaluate across all our different models and all our different stuff. So we can use autoplot on fit workflows. And so now this is going to show the metrics for our different models. So you'll note, so the model type red is boost tree, and you'll see that we have 10 different models here because we tried 10 different combinations of that. Excuse me, is it 10? No, it'd be 20.
More than 10.
It'd be 20 because we have the 2 different recipes.
Two, yeah. Mm-hmm.
For linear regression, there's only the 2 different recipes, and so it only appears twice. And for random forest, you'll also see a wide chunk here. And so what I think is interesting with this, not too surprisingly, Boost Tree does well. Slightly better than random forest, which I think is pretty standard if you tuned it correctly. But we have a lot of them here that are pretty close, and then we have a couple like just way off. So apparently these were overfit or way underfit or just did not perform well. But that's why you look across the workflow or the different problem space and run that. And so, but great, now we could see that, but we really want to select the best one. And so we can then rank the results of our workflow set based on whatever metric that we care about. In this case, I really care about accuracy, basically being as accurate as we can be. How close can we be to the ground truth? And so we can use the rank results on the fit workflows. We're going to use the rank metric RMSE, so root mean squared error, and select the best. So this way it limits the number of potential potential models to only be a single one because we tuned, so that as you saw in there were a fair amount more. Here it limits it, so we don't have a ton of random ones. And we can see the best one looks to be this boosted tree here, recipe 1, or am I just totally
That's the top ranked one. Mm-hmm. And so it has a mean RMSE across all the model of that, across the crossfolds of that as 0.609, and it has an R-squared, the proportion of variability being explained by the data as a 0.52, 52%.
There you go. So now we're doing pretty good. Patrick, do you want to take us through this piece? So now we fit everything.
Yep.
Let's pull it all out and take it home.
Yep, take it home or use it on new data. So start out there at line 229, where we're just going to assign metric to be RMSE. That's going to be the metric that we want to use to get the results, extract the workflow. So in this case here, what we do is we actually take that tibble called fit workflows, and we rank the results based on our metric RMSE, and we use select best to get the best one. And then we're going to slice that out and pull that workflow ID from row 1. So we're slicing row 1. We're going to pull that workflow ID, and that's going to be the ID that we talked about, recipe _1 _boost _tree. And then we're going to use extract workflow, as we've done in the past, to take our workflow and say the ID that we want to extract out is going to be the best workflow ID. And so there we see the full workflow. So this is everything that you would need if you were to then say apply this model to new incoming data. The model, the workflow right there knows exactly what to do. So it knows how to pre-process the data. It knows what steps to go through in the pre-processing, and then it knows the model type to use and what the arguments are. So we've got that pulled out. We've got the best workflow. And now we're going to extract the tuning results from the workflow set. So we're going to take that workflow set. So this is a little bit tricky here, right? So we're going to take the workflow set, and we have our workflow ID being the best workflow ID. We're going to go into the results component of the fit workflow. So if you were just to run that, you get returned, yep, there's your fit workflow. And then if you were just to run this, the results piece, you get this list from a tibble. And so we're going to use some list type of notation here to say, hey, get into the first element of that list. And that gives us these tuning results. And then we do that one more time. And there we see our tuned 5-fold cross-validation. And so we're going to yank that out. And there it is. So now we have the best tuned workflow. And so now we can collect the metrics across that. Cool. We can auto plot it. So there we see RMSE and R-squared on the vertical, and then across the top, we have the type of tuning parameters that we requested when we set the model recipes. Okay. And where were we? Oh,
sorry. There we go.
Yep, there we are. And then we can select the best using RMSE, which is going to have an mtry of 1,796 trees with a tree depth of 15. Okay, cool. So we're going to go ahead and fit the final model. So now we're going to bring it all home. We're going to finalize our workflow with the best workflow, selecting the best tuned model using RMSE. Again, we'll just register a few different cores here, and then we're going to apply this to the initial split data. So what this is doing is it's fitting to the training data now. It's fitting that best tuned model to all of our training data, not just the folds now, just the whole data as in itself. And then it's going to take that and fit that to the test set. And then after this is done running, we'll be able to collect the metrics on that test set, plot it, see how well the model did on data that it hasn't been built on, and all of that fun stuff. So this should only be a few more seconds to
it takes it shouldn't take too terribly long.
Run.
I put all the different cores, all the cores that I have.
There it is.
There we
go. And now we're all set, and we can take a look at what we've got. And we've got our train test split there in the ID. So we've fitted on the training set, we've tested it on the split set, and now we can extract those predictions. And you want to go ahead and walk through the final piece here?
Sure thing. So this is once again trained on the test data set, and then these are the results against the test data set here. So the RMSE is 0.586, and the R-squared is 0.536 for our best model that we could create here. So that's not too terrible. I mean, you might want to... There might be more stuff that we'd be able to do with this if we wanted to. Maybe try a larger space of different tuning
or
parameters.
Change it to classification and or the classification orders, like the probability of the person grading this a 4, a 5, a 6, a 7, given the features.
Yeah, maybe
different
adjust
options.
it that way as opposed to just doing a simple regression. But this was to demonstrate this as well. We can collect the actual prediction results using the collect predictions function. And so we're going to assign that to fit test. And so this is the prediction that our model has for the score that somebody would potentially give that wine. And this is the actual quality score that we got here. And so we could actually plot that, going ggplot with the data set fit test in there. We're going to set the aesthetics. The x-axis is going to be quality. And we're going to just turn this into a factor just so it's a little bit easier to plot, and we're going to set the y to be .pred, which is the predicted values that we have here. We're going to create a genome box plot so that we could maybe look at the spread of our predicted scores, as well as adding a genome jitter. So this is going to basically take our points on the x-axis and kind of just jitter them a little bit so that they aren't super overlapped, because otherwise they'd be all along a vertical line here. And we set the aesthetic or alpha to be 0.1 so that they're fairly easy to look through. As you can see here, I mean, we didn't do too terrible. I mean, there's a couple that are fairly high. Like there's one that we predicted to be a 7 when the person scored it a 5. But I mean, how far off really is that?
You could also see most of the dots are contained in 5 and 6.
That as well. And so
you could also set the colors probably to the wine type, and maybe see if we're doing better with reds or
oh yeah
whites, right?
Yeah, let's look at that real quick.
There you are.
And then let's set the aesthetic. What would it be? Color is equal to 1. Oh, it doesn't have that in the output.
Oh,
we need to merge that in.
Oh, I see. Okay.
I mean, we could do that. So bind calls, and this would be the train. No, test.
Yeah, test.
Like that, and then this would be wine type. Believe that is the logical. No.
Quality 4.
Oh, because this would have. No, not new. Select minus quality. Otherwise, it's duplicating quality.
Sure.
So, I mean, that's kind of hard to see. Let's remove
the red is the red, and the white is the green. Looks like little less alpha. There we go.
Yeah. So I mean, you know, not too terrible. I mean, it looks like there's a little bit more variability in the white, but that might just be the jittering.
It does look like there. Yeah, I mean the red has like some clear cut lines in certain points where people are pretty bullish that that's a 5 or 6. I mean, actually, like that's because the factor quality, the x-axis, is saying this is a 5, and then our prediction is a 5. So it's like,
yeah,
these are all the 5s actually. So maybe it's a little bit better for the reds, maybe.
There,
yeah, we try like that.
There or not wine quality.
Type.
Yeah. Am I just being?
You need a plus sign after geom jitter. No, you had it.
Oh,
it's a plus sign. It's not a yeah. And then tilde in front of the wine type, not after it. Yeah, now you get it.
Derp.
Boom. There we go.
Yeah, there's also more wine.
There is just more wine. Yeah.
More white wine. So
it's interesting. Like, look at the red number 7. There's a bunch that are just up at our upper quartile, our 75th percentile, as like 7, but our median prediction for
is a little bit lower. So maybe there's a little bit of like, a little bit.
Yeah. Interesting. It's cool.
Interesting to see. So we don't tend to predict higher than a 7.
No,
with our model here. So there's a little bit of like bias in our model because of the scoring that happens. But we can also do a quick confusion matrix, so we can convert our numeric predictions. We can round them to an integer value, select them out, and do a quick little table here to look at that as well. I mean, it's going to show us basically the same thing, that if we're going to be in the ballpark, but I mean, it's just kind of safe to predict a 5, 6, or 7.
Yeah.
And you're going to be in the ballpark. And then similar idea to what we also just showed before, but this time rather than using a box plot, we're going to use a violin plot to compare the integer prediction against the factor prediction. So, I mean, generally lining up how you'd expect it to, but just different ways you maybe could look at your model. And then the last thing that I wanted to do was look at variable importance, because we made sure to pull those out. And so you can extract the workflow and then extract the fit parsnif and then throw it into the VIP function from the VIP library, variable importance. And I'm going to do geom call just so that I can have a column as opposed to a point there. So now it's going to be extracting the variable importance and calculating that. And so it looks like for the wine that we were looking at, the most important variable for identifying the quality of wine was the alcohol content.
It's interesting because is this the variable importance for the random forest or for the XG boost?
XG boost.
Oh, okay. Oh, because it's the best final. Yeah, okay.
Yeah. And so it looks like alcohol has a big impact, volatile acidity, density, but alcohol has the biggest impact on that. So maybe there's
maybe it's when
curve.
The drunker that you get,
and then
the drunker you get, the more the higher chance of you giving it a better score.
A better score.
This is a great wine. I really like
Yeah,
it.
yeah, but I think this is interesting also. Like, I would expect maybe the residual sugar to have an impact, but like an inverse, because I don't know. I think people tend to like be like the white wine. White wine has a lot of potential residual sugar. So
Interesting.
impacts on that. Sulfates, pH doesn't look like it has a massive impact, but it does have some.
Yeah.
So I don't know. It's just ways to maybe look at your wine and think about your wine, and don't take this as a hard and fast rule, because clearly our model didn't do particularly well. But that is how you could maybe tune a bunch of different models. We could also have it look at a much wider space of tuning parameters to see what if we could improve our model anymore. But with that, I think we can call it, because that is how you tune a workflow set.
Yeah.
Tune your models that are in a workflow set.
There you go.
So if you like what we're doing, please comment below. Please like the video. We really appreciate it. It lets us know that we're doing a good job, and the more you like and share it and comment, the more it's going to share it with other people as well, so that it can get out into the world that what we're doing is helpful to people. So we like to help people. And then also, if you like what we're doing, please sign up to be a patron on Patreon, just so we can grab a coffee, or if you just like what we're doing. We're not going to hide this stuff away from you all if you don't sign up, though. So yeah, with that, let's call it. As always, my name is Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And my name is Patrick Ward. You can find me on Twitter at OSPPatrick. Tidy Explained is on Twitter at Tidy_explained. You can drop us a Gmail, tidy.explained@gmail.com. You can drop us a question on the GitHub repo if you open up an issue, or you can drop us a comment once you like and subscribe that YouTube link. You can drop us a comment on the bottom, and we'll try and get back to you, or maybe answer your question on an upcoming show.
All right. Thank you all so much, and keep on exploring your world.